Let's talk about computing the inverse of a function. I'm going to do two examples in this video. You can see the one I have on the screen here, and then the second one I'll do is this rational function at the bottom. All right, so we've been given the problem, compute the inverse of this function. And we always start this type of problem with the same few steps. So the first step we're going to do is just take this f of x and replace it with a y. We're just going to do some algebra with it, so it's easier to have that as a single letter, so it doesn't start to look more and more like multiplication. All right, so the second step is always to swap all the y's to x's and swap all the x's to y's. So in this particular example, there's only one x and one y, so they're going to trade places, and that's what makes it the inverse. And the next example will have more than one x that turns into a y. All right, so I have x equals the cube root of 2y minus 1, and then the plus 4 is outside of that cube root. Okay, so our next step is the most involved step of the inverse process, and that is solving for y. So right here, after we've made the x and y swap, now the y is kind of buried in the formula, and we have to dig it out. So your first step is to just put y in for the function notation, then swap x and y, then finally solve for y and put the function notation back in. All right, so to solve for y, I want to start peeling things away from it. Because the 2y minus 1 is stuck under this cube root, the first thing I need to do is subtract the 4 from both sides. So I get x minus 4 equals the cube root. Now that the cube root is alone on the right-hand side, I can undo it by cubing both sides, which is just raising both sides to the third power. And I'm going to write this in for clarity. So the cube root and the third power undo each other. So I'm going to raise both to the third power. On the left side, we have x minus 4 cubed. And on the right, now just the 2y minus 1 is left over because the cube root and the cube canceled the same way that a square root and a squared would cancel. All right, so we're trying to solve for y, and now the y is a lot more accessible. So I just need to add this 1 to both sides and then divide this 2. So last step is divide by 2. And I'm there. There's lots of options for how you could write this expression algebraically. Anything equivalent to this is fine. So you could also do, 1/2 x minus 4 cubed plus 1/2, where they each kind of get the two separately. And of course, you could spend the time to actually multiply out x minus 4 cubed up here, but none of those things are required as part of your answer. All right, so my very last step now is to just take the y and swap back in the function notation. But now that we've done all this, it is f inverse. So f inverse of x is this whole formula or any version of it that you'd like. There we go. Now, some of these inverse problems end with kind of a weird domain situation where you say not just f inverse equals this formula, but then you also kind of restrict its domain. For example, if this had started with the square root of some stuff plus 4, its range would be 4 to infinity, right? Because the square root puts out just positive numbers, and then you add 4, so 4 is the lowest. And then we would restrict the domain to be that same 4 to infinity. We don't need to do that here, though, because it's a cube root instead of a square. So this cube root actually outputs every number, right? Positive numbers, negative numbers, 0. So this range is everything. So this guy's domain is everything, and we don't have to make any special comment on it. Okay, now to our second example. We have the inverse of x plus 3 over 2x minus 5. This is a really common type of function that you see for this, this computing inverses section. It's a rational function, meaning it's like a polynomial fraction. And for us, for these inverse problems, it'll be a line equation over a line equation. The algebra steps in this type of question, they're kind of annoying, but they're always exactly the same. So once you get the hang of it, it'll work for any formula that starts looking like this. So we'll follow the same few steps as before. First, I just sub in a y instead of f of x, so I can do algebra with it. And now I'm going to swap the x's and y's. And this is where I was talking about how there's two x's in the formula. So both of these will switch to y. This y switches to an x. So we end up with x equals y plus 3 over 2y minus 5. Now that we've made this switch, our task is just to solve for y, which is a much more difficult task than in the previous problem because the y is in two places here. So this is where we're going to follow the same steps for these rational functions. First, this fraction is causing problems, so I'll multiply both sides by its denominator. So both sides get times 2y minus 5 in this case. And then I'll distribute this x into the parentheses. So right about here is where people usually get kind of lost in the problem. So we are solving for y. So at this point, you want to identify all the terms that actually have a y in them. So this term right here has a y, and so does this one. So that means I want to get those terms alone together so that I can factor that y out. It doesn't matter if I collect them on the left side of the equal sign or on the right, it's the same amount of work. And the answer will come out equivalent no matter what. All right, why don't I collect them on the left side? So I'll subtract this y over to the left. And then I'll subtract this 5x, or really add this 5x onto the right-hand side, so that these two terms are together and alone, right? So all the y terms on one side, all the non-y terms on the other side. Okay, so now that my y terms are alone together, I can factor the y out. They each both have just a plain y in them. So I can pull the y out, almost like I'm undistributing it. So this term with the y divided out is 2x. And then we have minus a y with a y divided out is like y over y, that's 1. This step can be a little bit tricky. If you want to double check yourself before moving on, you would just distribute the y back into the parentheses, and you should, as long as things went smoothly, wind up with the line above. All right, so my double check works out here. So now my very last step, I'm actually only one step away here. I just need to divide by everything in these parentheses, right? So now it's just y times some stuff equals stuff. So I just divide by this and I've solved for y. My answer comes out to be a big giant fraction, but it's the same type of function that I started with. So it's actually just fine. Just like the last problem, I'm going to take one extra step and just instead of y, put that function notation back in and use that same formula. All right, so that's my answer. You may have been following along doing the putting the y terms on the right side instead of the left. It's actually good practice to do that here. So instead of subtracting this y over and adding the 5x over here, we kind of swap and subtract the 2xy over and subtract the 3. So you have y terms on the right, non-y terms on the left instead. In that case, this answer would look different, but still be equivalent. What's happening then is every single term in this answer is going to flip its sign. So the 3 becomes -3, 5x is -5x, and so on. These two fractions are equivalent to each other, so they're both correct answers. The last thing I'll say is whenever it starts as this line formula over line formula, don't sweat the domain part of the problem. It's going to be invertible. Don't worry about domain restrictions. This one will just leave as our final answer with the formula.